So climate change. This is a very basically frightening picture of the Earth. Are we heading to kind of arid scene in the Earth? Basically, there are two groups of thoughts. Some scientists, they think that it's just climate variability. It's not climate change. It's not going to be irreversible. I'm going to discuss, as a scientist who's coming from UN, I'm going to discuss that it's climate change, and I'm going to somehow give you some evidence that why we believe it's climate change. This shows basically before Al Gore comes on the board and we get famous because of his cloth. We generated this intergovernmental panel on climate change assessments, basically starting in '92. And in 2001, we generated this figure. So it shows from 1,000 years ago to date, basically goes from past to present, just the deviation in temperature from the mean from 1961 to 1990. So if 0 is the mean, you can see that how temperature changed. And usually it was between 0 to minus 0.3 degrees deviation. And look at where we are today. I don't know, I think we plotted the 3 standard deviation as well on this plot. It's not shown here because it's in gray. The 3 standard deviation ends at this point, at 0.5. We are well above 3 standard deviation with the measurement in 2002, 2001, 2002 winter. So it means that we are well above the natural variability of the system, even within the 3 standard deviations that I think I can talk about it to engineers. So basically, both climate variations, all those oscillations, and climate change are caused by external forcings on the system. If we consider the Earth and its climate, its atmosphere around it as one system, we need to have external forces on the system to change the equilibrium of the system. Are they predictable? Partly. The system is highly nonlinear and is chaotic. So by doing modeling of the atmosphere, these are big computer models that basically it's like the Earth with its atmosphere and ocean. We are running them, and they are based on the physics principles, and we can partly say what's going to happen in future. So this is a very busy slide. The only thing that I want you to remember is that basically, yes, it's great. We have the oceans as hydrosphere. We have the atmosphere with all these gases that you hear in the news all the time, especially about carbon dioxide, water vapor, nitrous oxide, and methane. We have biosphere, basically we are all part of that part, and we have the sea ice and ice sheets and glaciers. But the external forcings of the system, the first one is the sun, basically what we receive from the sun. If that input changes, basically there is a force on the system. The other one is human influences. We start building these power plants, these manufacturing sites, and basically all of that influences the atmosphere. So, are we in radiative balance? Basically, Earth, whatever it gets from the sun. At every second, we get 340 joules of energy at every square meter of the Earth from the sun, in terms of ultraviolet and visible. And then part of it gets reflected back by the dense atmosphere around the Earth. So about 100 watt per meter square gets reflected back. The rest comes somehow to the surface of the Earth, either re-radiated by the atmosphere, and then again it goes back now as infrared, as heat. Basically the Earth 24/7 emits heat to the space at a rate of 235 watts per meter square. So if we are at a radiative equilibrium, basically whatever we get to the sun, we should be a very good client and return it to the outer space. So the net radiation should be zero. Basically, the solar radiation and the heat radiated from the Earth should be equal. If we give back to the outer space less than we receive from the sun, basically we are going to get warmer. If we give more back to the outer space than we get from the sun, we will be cooler. Am I representing this right? If we are at the radiative balance and I do the calculation, the effective temperature of the surface of the Earth is going to be minus 18 degrees, like a cold day in, I don't know, February in Toronto. And apparently, the whole Earth, because this is the mean temperature of the Earth, of the whole globe, we are not standing at minus 18. Otherwise, the life as it is right now wouldn't have been. We are standing at 14 degrees, basically, as the average temperature of the Earth. What causes this is basically the natural greenhouse effect. So we are always talking about greenhouse gases like they are terrible agents of climate change. If they weren't there, if we didn't have carbon dioxide, water vapor, methane, or nitrous oxide, we wouldn't be here. You know, the Earth would have been something like Mars that has no atmosphere. Basically, the atmosphere is not as thick as the Earth and can't have the natural greenhouse effect. So greenhouse gases are good things. Basically, they made life possible. These are the four most important ones. Usually, you don't hear about water vapor in news because that has political aspects to it. So we start with carbon dioxide. And we are talking about how important it is because they capture that heat and keep it for us to be able to live in this atmosphere. However, if we start generating more than the amount that naturally is there, then they trap more heat, and more heat causes undesirable situation for us. If the last 1,000 years of data from ice cores didn't convince you that we are at the brink of a climate change, it's not just the oscillation of the system, this should do. We generated this in 2007, and it shows 650,000 years ago to date. So basically, you can see all the ice ages here. And look at what happened to CO2. Basically, the average CO2 was 275 parts per million per volume. So that's just the volume mixing ratio. And now we are standing at 375. Look at this last part of our existence when Otto called it Industrial Revolution. Look at methane. Basically, we went from average, you know, the peaks happen at 600 ppb. And now we are at 1700 ppb. So the situation is not just the oscillation of the system. Yes, the system oscillated and we got the ice ages, but we've never been into